Hey everyone, welcome back. So today we're diving into a really fascinating explainer. We're setting our sights on a massive hurdle in the world of artificial intelligence, specifically how AI listens to and actually grades synthetic speech. For the longest time, we've had this frustrating black box problem, where the AI gives us an answer but absolutely refuses to explain why. Well, today we're unpacking a brand new framework that finally teaches AI to, well, show its work. Let's get right into it. The paper we're looking at is titled UniSRM, a unified speech reward model for reasoning-based fine-grained assessment. And it brings together some seriously brilliant minds from the Chinese University of Hong Kong, Tsinghua University, alongside independent researchers. They've essentially teamed up to tackle a fundamental flaw in how AI evaluates audio today. And honestly, their proposed solution is just as elegant as it is powerful. Okay, really quickly, here is our roadmap for this explainer. We'll meet the UniSRM paper and define the black box problem. Then we'll look at the transparent solution and the unique two-stage architecture they use to build it. Finally, we'll wrap up with why UniSRM matters and its future applications. All right, Section 1, meet the UniSRM paper and the quest for better AI speech. And moving right along to Section 2, the black box problem, or what happens when AI just can't explain itself. So, to set the stage here, autoregressive large language models have literally revolutionized natural language processing, right? And that's led to a massive surge in using reinforcement learning to align these AI models with human preferences. But applying this exact same logic to speech generation, yeah, it hasn't been quite so straightforward. Imagine you're asking someone how a meal tastes, and they just say, 7. And then they completely refuse to elaborate. Like, was it too salty? Was it cold? You literally have no idea. And that is the exact frustrating reality of our first major challenge here, a sheer lack of transparency in scoring. Add to that 3 other big issues: incomplete evaluation dimensions, limited task coverage, and totally insufficient supervision over the AI's reasoning process, and you've got a fundamentally flawed old method. Relying on this black box scalar prediction causes massive inconsistencies between what the model might actually be thinking and the final score it spits out. Which brings us to Section 3, a transparent solution, and how we are finally teaching AI to show its work. Think back to being in school, right? Remember how a math teacher would always demand that you show your steps, rather than just writing down the final answer at the bottom of the page? Well, that is the exact paradigm shift we're seeing here. The old way relied on black box scalar prediction. It was just a final score, completely opaque. But the UniSRM way? It introduces fine-grained, interpretable quality assessment. So instead of just handing us a single number, the model provides a really rich set of multidimensional reward signals, which creates a completely transparent grading system. But you're probably wondering, how does it actually do this? Well, it pulls this off through a really clever structural formatting trick, using XML-style tags. Basically, UniSRM is trained to generate its intermediate reasoning inside a pair of think tags. Inside these tags, the model explicitly has to describe things like noise, distortion, any unnatural pauses, and just the general feeling of the voice. This all culminates in a natural language description. And here's the kicker. Only after it has generated this entire reasoning trace is it actually allowed to output the final structured score inside an answer tag. By forcing the generation of these textual rationales, the AI takes abstract audio concepts and grounds them into tangible, highly interpretable text. It's brilliant. All right, Section 4, the two-stage architecture. Let's see how they actually built this model from the ground up. So the architecture here is built in a dual-stage framework. Step 1 is supervised fine-tuning. This is where they take an existing data set, specifically the textual rationales from quality speech, and treat that as the model's intermediate reasoning. It's basically where the model learns to connect 7 very distinct aspect scores to specific descriptive language. Once it actually knows how to assess quality, it graduates to Step 2, reasoning consistent GRPO. Now, this is a reinforcement learning policy optimization stage. Here, the model is fine-tuned to perfectly align all of those detailed reasoning capabilities with actual human preferences. Now, to make absolutely sure that the limited task coverage problem we talked about earlier is completely solved, the researchers built a massively comprehensive, multifaceted data pipeline. At the very top, they're taking open-source text-to-speech models, pairing them up, and then running them through large models like Gemini to generate multidimensional explanations for A/B preference judgments. Then, moving down the pipeline, they leverage that quality speech dataset for utterance-level quality assessment. They also use context from the ESD dataset to evaluate scenario-aware style consistency, and finally, they bring in the daily talk dataset to evaluate multi-turn dialogue speech. Honestly, it's just a huge, robust approach to teaching the AI exactly how to listen. Section 5. Why UniSRM matters, and the massive impact of interpretable AI. So, what's the bottom line for machine learning practitioners? Well, it's pretty profound, actually. The researchers' experiments demonstrate that UniSRM yields judgments that are not only way more reliable, but also far better aligned with human preferences. Think about it. When you force an AI to literally reason out loud, to write down its thoughts about the noise, the distortion, those weird, unnatural pauses, its final decisions become incredibly trustworthy. We can literally just look at the output, read those think tags, and say, okay, I see exactly why it scored this audio a 4 out of 5. It makes the entire development pipeline for synthetic speech so much more robust and vastly easier to debug. And finally, Section 6, Future Applications, and what is next for synthetic voices. I want to leave you all with a bit of a provocative thought here. If AI can perfectly grade and reason through speech quality, what does that actually mean for the future of synthetic voices? Think about it. If developers can use UniSRM to instantly and accurately get feedback on exactly why a generated voice sounds slightly off, that iteration loop becomes lightning fast. We are very likely looking at a near future where synthetic speech becomes completely indistinguishable from human speech, all guided step by step by these highly interpretable reward models. It is a real game changer. Anyway, thank you so much for joining me to unpack this incredible research. And as always, keep learning.